Okay, grade 12. So for the next 3 days, I won't be here. So you're going to use these recordings, hopefully get these notes done. Absolutely pause if you need some extra time to write down the question, write down the answer, okay? So pause it whenever you need to pause it. Right off the bat, we're going to do some review. So when we're solving exponential equations with a common base, what you do is you make each base the same, and then you can set your exponents equal to each other. So if I have 2 to the exponent x is equal to 32, I know that 2 is a pretty small base, so I'm just going to leave 2 to the exponent x like that. And I can write 32 as a base of 2. So I can write 32 as 2 to the exponent 5. As soon as I have two exponents with the same base, I can set them equal to each other. So x here is equal to 5. In part B, I have 4 to the x equals 2 to the x plus 3. I can rewrite 4 with the base of 2. 4 already has that power of x, so make sure you write that in power. So I have 4 is equal to 2 squared. So it would be 2 squared all to the exponent x equals to 2 to the x plus 3. So I have 2 squared to the exponent x. I have a power of a power here. When I have a power of a power, I multiply my exponents. So 2 times x, 2 to the exponent 2x equals 2 to the exponent x plus 3. I have the same base. I can set my exponents equal to each other. So I have 2x equals x plus 3. If I want to solve these equations, that means I have to solve for x. So I have to get my x to one side, get my numbers to the other side. So this is just solving linear equations right now. So I want to subtract my x to get rid of on my right-hand side. 2x minus x is x equals 3. So that's how you solve these. Okay? Sometimes, though, when you're solving exponential equations, you can't change the base to make them the same. This is when we talked about before about changing an exponential equation to a logarithmic equation. So we can't do it because you can't change base 3. We already talked about that. So we're going to skip A and B. We're going to skip that part. We're going to go right to the bottom. We can write exponential equations as logarithmic equations. So you want to write this as log. You want your base to stay the same, so your base will be 2 at 50 equals x. So now you can put this into your calculator and you can solve. When you put this in your calculator, you're going to go log of 50 over log of 2. You always take the logarithm of your argument divided by the logarithm of your base. Okay, so you can see in class example 1 that you can't rewrite 7 with a base of 4. They want answers as exact form and then 3 decimal places, so we'll just do both. So 4 to the x equals 7, let's write into logarithmic form. Our base stays the same, so log, we have a base of 4 of 7 equals x. So we're going to put this in our calculator. To put it in our calculator, or to have an exact value, we would go log of 7 divided by log of 4 equals x. And then in our calculator, that's exactly how we would put it. So go log of 7, bracket, divided by log of 4, bracket, enter. So I want 3 decimal places, so it'll be 1.404. The 6 changes a 3 to a 4. So x equals 1.404. Yeah, 404. So that's where you would end there. In part B, it's a little bit different. You have h to the x equals, or h to the x plus 4 equals 40. So all you want to do is just subtract 4 from both sides to get h to the x. A to the x equals 36. Okay, you can't write these with the same base, so let's just put it in logarithmic form. So log, our base stays the same, our base is still 8, of 36 equals x. So to write this as a logarithm, or write this as an exact value, go log of 36 over log of 8 equals x. To put this into your calculator, log of 36 bracket divided by log of 8 bracket. Enter. 1.723. So x equals 1.723. So just make sure you know how to change from exponential equations into logarithmic equations, and how to put logarithmic equations into your calculator when they have a base that's not 10. So always take the log of your argument divided by log of your base. Okay, according to Stats Canada, 21st century, Canada's population has been growing at an average annual rate of 1.0%. Exponential equation p equals p naught times 1.01 to the n can be used to predict the population p in n years after a known population p naught. Okay, so p equals p naught times 1.01 to the n. We know that this is an exponential and that it's growing. So it's exponential growth because b is greater than 1. b is your 1.01. So it's growing at a rate of 1.0%. If you don't remember this, you might have to review a little bit from last unit. Okay, so the Canadian population at the beginning of 2001 was approximately 30 million. Estimate the year which the Canadian population will reach 50 million, assuming the same average annual rate of growth. So if the population at the beginning of 2001 was 30 million, that'll be your P naught. P naught is always your initial population. So if this is where we're starting, that'll be our P naught. If we're estimating when it'll be at 50 million, that'll be our P. So we have 50 million, which we actually write out. So 50, and then we have 6 zeros, equals 30 million. So 30 with 6 zeros times 1.01 to the n. So right now we're trying to find n. To find n here, you want to get 1.01 to the n isolated. So we have that coefficient in front of it. If we have a coefficient that's being multiplied to it, you want to do the opposite, you want to divide. So you want to divide both sides here by 30,000. Or sorry, 30 million. So if I divide both sides here by 30 million, I know that 50 million divided by 30 million, we can just simplify to 5 over 3 equals 1.01 to the n. If you want to go 50 million divided by 30 million in your calculators and get a decimal, that's perfectly fine. But if you can see that they can simplify to 5 over 3 as a fraction, that is even better. Okay, so now we have this exponential equation. We can't use the same base, so let's change this to logarithmic. So with logarithmic equation, our base will stay the same. I'll put this in blue. So we have log, our base is 1.01. Our argument is 5/3 equals n. Let's start calculator. Log 5/3, 5 divided by 3, close your brackets, divided by log of 1.01. Enter. 51.337 or 338. So n equals 51.338. Let's see if this is answering our question. So this n is years. So if the Canadian population at the beginning of 2001 was approximately 30 million, estimate the year in which Canadian population will reach 50 million. So if we're estimating the year, we know that it's going to be over 51 years. So we'll estimate to 52 years. So if we're starting at 2001, so we have 2001 plus 52 years, it'll be about 2053. That'll be our estimate. So always make sure to double check that question and answer it properly. Because if you just said it'll take 51.3 years or about 52 years, you're not going to answer the question correctly. On the diploma, you will not get that right, okay? Okay, solving exponential equations using a graphing calculator. We did this a little bit before last week by using the intersect function, so we'll do that really quick on my graphing calculator. So if I give you an exponential equation, you can always graph it. This is actually a pretty good check mark test. So you can do an exponential and then change to logarithmic and solve that way. Or you can just graph it in your calculator, find the intersect, do both. If you get the same answer, 100%. So let's graph it. So I have 4 to the x equals 7. I'm going to graph 4 to the x in my y1. I'm going to graph 7 in my y2. Okay, my window, I'm going to make the same window that they have. So my x min is -1. My x max is 4. My scale is 1. And my y min looks like -7. Y max is 10. The scale is 1. Let's graph it. Okay, so you guys are going to draw this graph into yours. I'm just going to drag it here so it's easy for me and because I can cheat that way. Okay, so this curved one, I'll just label, is 4 to the x. We know because it's exponential. So we did y1 equals 4 to the x. And then the straight graph is 7. So we did our y2 is equal to 7. So right here, this big dot, that is our solution. So we go into our graph. We have them two crossing each other, so let's find the intersect. So second trace. Number 5 is intersect. Enter, enter, enter. When y equals 7, our x equals 1.4036. 3 decimal places. So 404. So x is equal to 1.404. If you can remember, this was the same question we had on that last page in 1A. So this just shows you that doing it both ways, you can check your work that way. You have the same answer, 100%. Okay. Solving exponential equations using logarithms. Okay. More complicated exponential equations having two variable exponents, for example, 6 to the 3x equals 3 to the 2x minus 1, cannot be solved by simply converting to logarithmic form, although the method of solution still involves logarithm. If two quantities are equal, then the logarithms of two quantities are also equal. So the equation 6 to the 3x equals 3 to the 2x minus 1 can be solved by taking the logarithm base 10 of each side, solving the resulting equation for x. So complete the work started below and determine the exact solution. So we'll do the exact solution first. So I have both equations. So at first I'm taking the logarithm of 6 to the 3x. As soon as I have this exponent, this is your power law, put it out in front, okay? So they put it out in front, same here. This 2x minus 1, put it out in front. If you're taking a power or an exponent out in front and it has different terms, make sure to put it in brackets like they did here, because you're multiplying that entire binomial by log of 3, not just the -1. So on the left-hand side, I'm just rewriting 3x log of 6 equals. So now, all they did here was distribute the 2x to the log 3 and -1 to log 3. So 2x log 3 minus -1 log 3. So if you just minus log 3, you can subtract the subtract +1 log 3, or just subtract log 3. Either way, this is how you would write that out. Okay, so I have 3x log 6, and then all we're doing is subtracting 2x log 3 from both sides. So we have 3x log 6 minus 2x log 3 is equal to -log 3. The reason why we did this step right here is to get x's to one side. So if I get all the x's to one side and all my numbers to the other side, this is how I solve for x. Because I have 3x log 6 minus 2x log 3, I can factor out x. So if I factor out that x, I'm left with 3 log 6 minus 2 log 3 minus -log 3. So I know that I can solve 3 log 6 minus 2 log 3 because I can put that right into my calculator. So 3 log 6 minus 2 log 3. I have negative log 3. This is on my right-hand side. I'm just going to put these over here for now. Okay, so I have two different answers. I have x being multiplied to 1.380. And then I have negative 0.477 on the right-hand side. So what I want to do here is I just want to divide the two. So as an exact solution, our solution is just going to be negative log 3 over 3 log 6 minus 2 log 3. And then an approximate solution, I'll just put it all in main calculator all at once just to show you, would be bracket negative log 3, bracket, and then this closes, this is all your numerator, divided by bracket 3 log 6, close that bracket, minus 2 log 3, bracket. So this right here does all of that work at once, so you don't have to round anything. Okay, so your answer right here, and it wants the nearest tenth, would be negative 0.3. So I'm just going to put this over top of that one. So that's how you put that in your calculator. So x is equal to negative 0.3. So if you ever have two exponential equations with kind of crazy looking exponents with x's in both of them and binomials, this is how you would solve it. Okay, so use the above method to solve the equations. I think I have these covered right now. There we go. Okay, 2 to the x equals 32. And b for the x equals 2 to the x plus 3. We're just going to do b for now. Okay, so if you want to do a, by all means do that, but we'll just do b as a class. So 4 to the x equals 2 to the x plus 3. I'll just scroll up a little bit so we can see both, or we can see our previous work. Okay, so the first thing we do is put them in logarithmic form. Okay, so I can just rewrite this as log 4 to the x equals log of 2 to the x plus 3. All I do here is put logarithm in front of both, okay? So if I put logarithm in front of one side and put it in front of the other side, I'm not going to change either side of the equation. So all I'm doing is put that logarithm sign in front of both of these. I'm not actually changing my base, I'm not changing my value, I'm not changing my argument. All I'm doing is just put log in front of both of these. So now that I have this, take your exponents, move out in front. So if I take that left-hand side exponent out in front, this is equal to x times log of 4, and then it'll be equal to, don't forget brackets because it's a binomial, x plus 3 times log of 2. I'm just going to rewrite the left-hand side because there's nothing there that I can change. And on the right-hand side, I'm going to distribute my x and my 3 and multiply them both to log of 2. So this equals x log 2 plus 3 log 2. So now I have x's and numbers on both sides. Let's get all my x's to the one side. It's positive on the right-hand side. We can subtract it. So all I'm doing right now is I'm going to subtract x log 2 from both sides. So on my left-hand side, I'm left with x log 4 minus x log 2 is equal to, so those will cancel out. I'm left with 3 log 2 on my right-hand side. Now that I have x's on the one side, numbers on the other, let's factor out the x. So if I factor out the x, I'm left with log of 4 minus log of 2 equal, and I still have 3 log 2 on the right-hand side. I have x being multiplied to all these logarithms, so let's divide. So if I divide both sides by log of 4 minus log of 2, I still have 3 log of 2 on the right-hand side, divided by, and now I'm divided by all of log of 4 minus log of 2. So this right here is my exact value. So let's put in our calculators to figure out the rounded value, okay? So if I have numerators and denominators, put your whole numerator in brackets. So I have 3 log 2, bracket, close your brackets for your numerator, divide, bracket, log of 4, bracket, minus log 2, bracket, enter. Answer here is 3. So x is equal to 3. If you went back and saw in that previous example, your answer is 3 there as well, so you're 100% right here. Okay, last page. Show that the solution to the equation 4 to the x plus 2 equals 7 to 2x plus 5 can be written in the form x equals 5 log 7 minus 2 log 4 divided by log 4 minus 2 log 7. So we're going to evaluate. So right now we're just going to start right off the bat as writing the equation. So 4 to the x plus 2 equals 7 to 2x plus 5. So first step, just put logarithm in front of both. So log of 4 to the x plus 2 equals log of 7 to 2x plus 5. Just put logarithm in front of both, leave the bases and exponents the same. Now that you have these, take your exponents, move them out in front. Use your power rule. When the exponents are binomials, put them in brackets. Okay. Now that I have a binomial times a monomial, use your distributive property, multiply your x by log of 4 and your 2 by log of 4. And same with the second one. Multiply your 2x by log of 7 and 5 by log of 7. So my left-hand side, x times log of 4 is just x log 4. And positive 2 times log of 4, so we're just adding 2 log of 4, equals. I have 2x times log of 7, so this is just 2x log 7, plus, and then 5 times log 7 is just 5. The biggest difference on this one is you have x's and numbers on both sides, so you just have to subtract. It doesn't really matter which way you go. So I'm just going to subtract 2x log 7 from both sides. So now I have all my x's on my left-hand side. And I have this 2 log 4 on the left-hand side too, so I just want to subtract that from both sides. So now I only have x's on the left-hand side and numbers on the right-hand side. So I have x log 4 minus 2x log 7 equals to 5 log 7 minus 2 log 4. I'm just going to start up on the right-hand side. Okay, so now I have x's on one side, numbers on the other. Let's factor out our x. So on the left-hand side, if I factor out an x, I'm left with log of 4 minus, and then 2x log 7. If I factor out x, it would just be 2 log 7 equals, and then I'm just going to leave the right-hand side alone. 5 log 7 minus 2 log 4. Divide both sides by log 4 minus 2 log 7, so x is equal to 5 log 7 minus 2 log 4 divided by log of 4 minus 2 log 7. You can see that that answer is the same as what they had here. So now let's evaluate 2 decimal places. Brackets are pretty big here, so make sure you put your numerator brackets, put your denominator brackets. So bracket 5 log 7. Close that little bracket. Subtract 2 log 4. Close that bracket, and then close the numerator bracket. Divided by bracket log of 4 minus 2 log 7. Bracket, bracket. Enter. 2 decimal places, so it would be 8.31 is your answer. I don't think that's right. 5 log 7 minus 2 log 4 divided by, oh, I did this wrong. Okay, 5 log 7, I'm just going to do this again. 5 log 7 bracket minus 2 log 4 bracket, bracket. Okay, that looks good. Divided by bracket. Log of 4. Close that bracket. Minus 2. There we go. Log of 7. Bracket, bracket. That looks better. So our answer to 2 decimal places, negative 2.78. So I'm just going to put this on here. I'll save all of these notebook files. So if you guys want to go back and look at these, that is fine. So I'll save them so Mrs. Nichols can put them up if you need to copy notes if I'm going too fast. And last example. So note, you can take log of each side of any exponential equation to any base, but it's simpler to use calculator base. The base of the exponential equation is e is simpler to use natural logarithms. So we talked about this, natural log, your base is still e, to solve the exponential equation as in the example below. So solve this equation, 7e to the negative 2x plus 9 is equal to 12, expressing the solution. Okay, so the first thing we want to do, rewrite our equation. So we have 7e to the negative 2x plus 9 equals 12. Like any equation that we're trying to solve, let's just get x's to one side and numbers to the other side. So we're adding 9 to the left-hand side, so let's subtract 9 from both sides to get rid of that. So I have 7 e to the negative 2x is equal to 12 minus 9 is 3. I have this coefficient in front of my e. So I have 7 being multiplied to it, so let's just divide by 7. So I have e to the negative 2x is equal to 3 over 7. So now that I have this, let's just set it to our natural log. So same idea as before, all we're doing now is putting natural log. So natural log of e to the negative 2x is equal to natural log of 3 over 7. The natural log of e to anything would be the exponent. So if I were to move this out in front, this is just, I'm justifying why I just said that. So if I have negative 2x, natural log of e equals natural log of 3 over 7. If you put in your calculator natural log of e, this will be equal to 1. Okay, so left-hand side, we just have negative 2x is equal to natural log of 3 over 7. To isolate x, you want to divide by negative 2. So x is equal to natural log of 3 over 7 divided by 2. We can put this into our calculator. So we have natural log, let's put this in brackets. Bracket natural log of 3 over 7. Bracket, close that numerator bracket, divided by 2. Enter. I have negative 0.4 to 3 decimal places, negative 0.424. So there will be these notes saved, the notes can go up and they can be changed at your pace to finish copying this stuff down. Remember, you guys have a quiz tomorrow. The quiz isn't on today, but it'll be on changing from exponential to logarithmic functions. It'll also be on going from logarithmic to exponential, changing to the same base algebraically, solving for x that way. There is a product loss, so if I have a logarithm plus a logarithm, you're going to have to simplify it using a logarithm with your arguments multiplied. There's also power laws. So if I have a 2 in front, I can make it my new exponent. So just make sure you study the first 5 units, okay? So study the first 5 units for your quiz tomorrow. You'll have the whole first period. Marwayne is going to fax over the copies, so someone in Edgerton is going to have to make copies for everybody. It's all the same quiz. Make sure you guys sit far away from each other. Mrs. Nichols will be videoed in on everybody. You're going to fax over to Dewberry. They're going to make copies. If you guys can't make copies, then we can just fax it twice, okay? If you have any questions about anything, I will have my cell phone on me, so I will talk to them. Try texting me first, just in case I'm in an important meeting. But if I can get out of it, then we can just do a conference call and then put me on speakerphone and we could figure it out, okay? So good luck with the next couple days, you guys, and I will see you on Thursday.